So let's talk about writing more efficient queries. Obviously, writing better, faster, and more efficient queries is a goal for developers, but sometimes it can be a little difficult. What specific operations within queries can we improve? Well, this section is going to help narrow those choices by looking at areas that can cause performance issues. When you write a query that involves more than one table, there are different ways to resolve the data and return it as a single result set. We're going to talk about using the exists clause. We're going to talk about issues concerning joins and subqueries and how that affects performance. We're going to talk about one-pass queries, what they are, and how to implement them. First, let's discuss the exists clause. Within the logic of your queries, stored procedures, user-defined functions, you often have a need to branch based on the existence of rows. If SQL finds any rows that meet the search criteria, you want it to perform one action. Otherwise, go down another branch to do something else. In these particular cases, the point is not to retrieve data associated with those rows, but only to determine if there are any that meet the criteria. I suggest using the exists keyword rather than count. Using the count function is not nearly as efficient as using an exists. When we use count, SQL Server actually evaluates all the rows to determine the number that satisfy the conditions of the where clause. On the other hand, exists just returns a Boolean indicating if any rows satisfy the condition of the search. So as soon as SQL finds the first row, it halts its testing and stops looking at additional rows. Next, let's talk about the issues between joins and subqueries. In most cases, you'll want to rewrite subqueries as joins. Queries that use joins usually perform faster. And that's because SQL can execute the individual join statements concurrently. But if we use a subquery, it has to execute those sequentially. As you know, subqueries are T-SQL select statements evaluated by SQL Server individually, and their results are then applied to the outer query, which takes additional time. Subqueries may also contain clauses such as order by, which produces overhead, and that may limit SQL Server's ability to optimize the execution plan. Also, join queries will perform better if the columns you're joining on have their own indexes and they are the same data type. Note that columns containing foreign keys don't automatically have an index generated by SQL Server. So make sure you index your foreign key columns for better performance. Write a good where clause. Sometimes that seems a little obvious, but it's really kind of true. Take time to examine your data and write good where clauses. Joins between columns of numeric data types will actually perform better than joins between character-based data. That's pretty obvious because SQL doesn't have to do as much evaluation. Implicit data conversion between columns that are joined can cause SQL to abandon the use of an index, so be aware of that. You might want to explicitly cast them. Try to avoid joining columns that contain few unique values. The SQL Server may not use the index. And here's a tip. It's always a good idea to test both the joined and subquery version of a query. That way you can take a look at the execution plans, and when appropriate, take a look at the tuning advisor to determine which method performs better. Let's discuss one-pass queries. In those cases where you need to process data from the same set of tables but multiple times, and you're doing that within the same query, you might want to consider the implementation choices. If possible, it might be far better to use constructs that allow SQL Server to process data in one pass. The classic example of this is the case statement versus a union. When we need to segment results into distinct groups based on the values we find in the columns, the case statement may actually be the best solution. Let's head on over to SQL Server Management Studio and we'll take a look at some of these constructs. Okay, this quick example shows us how we're using the count function to determine the number of rows that satisfy a particular condition. And the point here is that we're taking a look at all of our orders that are due on the 15th of January 2008, and if by some chance the quantity ordered is greater than the amount that we have in stock, we need to notify our production teams to get going and make some additional product. So let's go ahead and just execute this. It's pretty straightforward. We do that and we find out that yes, indeed, we need some additional production. Okay, that's all well and good. But we also have to remember that we're working with a very small set of data. There aren't too many rows in the AdventureWorks database. So while this works very quickly and easily, if we're working with a very large set of data, millions, tens of millions, hundreds of millions of rows, would using count impact performance? The answer to that question is yes, because remember, count is actually going to examine every single row that satisfies the condition or conditions and return you a count of how many satisfy the query. If we take a look at the exists, this is a little bit different. Remember that exists is going to locate the first row, search for the first row that satisfies the conditions, and as soon as it finds one, it stops. All we're asking here is there at least one? If there's at least one case where the amount ordered is greater than what we have in stock, and it's due on this particular date, we need to get extra help in here to produce those items. So it doesn't matter if there's 1, 5, 10, we know there's something to be done. So using exist here is much more efficient. And if we execute it, of course, we're going to get the same answer. We're not surprised by that. But just realize, based on the volume of data, the exist clause is much more efficient than using a count. So let me go ahead and dismiss these two examples, and we'll start talking about one-pass queries. And what we're doing here is we're going to take a look at using a union statement versus a case statement. And in this particular example, we're going to examine the unions. And what we're doing here is we're just going to select some data from our customer database, and based on the amount of sales, specifically how much they've spent with us, we're going to put them into different categories. So here you can see that anybody who has spent more than $5,000 with us, we're going to consider a platinum level member. And we're going to continue to execute these separate select statements, breaking them into these different groups. So anybody between 3,501 and 5,000 is a gold member. Anybody between 2,001 and 3,500 is silver. And finally, between 501 and 2,000 is a bronze member. Each of those select statements will be executed and brought together using a union all. And that'll give us the results that we certainly want. It's not that complicated to do. But what we're going to see is, again, because we're dealing with a small database, that's not that difficult to do. We're getting back our customer levels. Everybody's being evaluated. It's fine. Again, when we move into larger data sets, this could be a problem. What if we had to look at a 5 million row customer database? Well, one way to handle it then would be to come back and deal with the case statement. Because again, we're going to evaluate every single row in the data set, which is not the problem. But again, instead of taking those 4 separate select statements, executing them, bringing them all back together, we're going to evaluate them as we go. And so here what we're doing is saying, look, let's take a look using a case statement, and based on the amount of money that they've spent, we'll in line assign them the appropriate category. And so when we execute this one, it's a much shorter query, which doesn't really equate to being more efficient, but it's a lot easier to maintain. It's a little bit more straightforward, and because it's in line, SQL will actually evaluate those rows at once versus having to do the 4 separate and then bring them back together. So just a few examples of how you could take advantage of some constructs to build more efficient queries. When you're writing complex queries, there's often a need to work with multiple result sets. And sometimes you need to store those results temporarily so that you can use them later on. Temporary tables is one answer. We could also use table variables to accomplish this. User-defined table-valued functions can help us with this, as well as common table expressions, work tables, and user-defined table-type parameters. When we use temporary tables, obviously based on their name, they're not permanent database objects. SQL Server creates and maintains them in TempDB, and when they're no longer needed, automatically deletes them. Some advantages to temp tables are: temp tables can have indexes. Temporary tables can have constraints. Statistics may exist for temporary tables, which will help SQL Server's Query Optimizer build a good plan. And if you have complex queries involving a large amount of data, these indexed temporary tables may be your best solution. Let's take a look at table variables. The table data type offers an alternative approach to temporary storage. These variables can store results for later processing, and table variables behave like local variables, as their scope is the procedure, function, or batch that defines them. Table variables have the following advantages. They're isolated to the batch that creates them. They actually result in fewer stored procedure recompilations. And you can use them in select, insert, update, or delete statements. They actually require fewer locking and logging resources, as transactions on them only last for the duration of the operation itself. SQL Server will automatically reclaim those resources when it's no longer in scope. Let's talk about user-defined table-valued functions. UDFs are functions like those found in other programming languages. Basically, they can accept parameters, do some operation, and return results. SQL Server actually supports multiple types of UDFs. Those include the inline scalar function, which includes returning a single value from the execution of a statement. There's also the multi-statement scalar functions. Those return a single value, but that's as the result of executing a series of T-SQL statements, and those statements are contained in a begin and end block. There's the inline table-valued function. That actually returns a table as the result of executing a single T-SQL statement. And finally, there's the multi-statement table-valued function. That returns a table data type as well, but that table is returned as the result of executing a series of T-SQL statements. And those statements are contained in a begin and end block. One of those statements, however, must be the one that inserts rows into that table. So there's some things you might want to keep in mind if you're considering using a UDF for your storage needs. A good thing is the modular programming approach. We could write this once and use it many times. It might execute faster. Like stored procedures, SQL Server will cache and reuse the execution plan. UDFs represent black boxes of reusable code, and we'd use them in the following ways. You could reference them within other T-SQL statements. You could use them within a definition of other user-defined functions. You could create parameterized views by accepting parameters used in the where clause of an encapsulated call to the view. And in some cases, UDFs are appropriate for replacing stored procedures. So let's go on over to SQL Server Management Studio and take a look at how we might use these. Okay, in this example, we're going to take a look at a table-valued user-defined function, how we create it, what it might be used for, and then how we could call it. And in this case, we're going to define a function called employee pay by department get. And this actually is going to encapsulate a call to a view. And what it's going to do is it's going to return a table that contains information that we're interested in, primarily a bunch of personal information along with the person's current job title and current rate, the department that they work for, and so forth. And what we're going to do is we're going to accept as our arguments here the ID of the employee, the department that they work in, and a rate change date. And what that rate change date is going to function as is, please give me back the information for this employee, these employees, employees of a particular department, whatever the combinations may be, as of the date that I send in. So this is going to be one of those, again, kind of those black boxes that we can send in a bunch of different parameters and get different results. So what we're going to do is, you'll see here, we are returning a table. That table is called TBLUDF results. And because we are doing a multi-step operation, we're going to need to insert the rows into that table before we can return it. Here's its structure. And once that's done, we're going to go along here and start gathering the data and building our results. The first thing we're going to do is we're taking a look at all the parameters that came in. If a business ID is not sent in other words, it's a 0, then what we're doing is that really indicates to us, hey, get me a list of all the employees. So we go ahead and we figure out what the min and max IDs are for our employees, and we can use those in our select down below. We do the same for our department. If they send us a department, that means please select the employees from that given department. Otherwise, I want to look at employees from all departments. Finally, we're going to check to see what the date is coming in, and if it's the end of time date, then we're going to assign to our local variable whatever the current date and time is. So we can actually have a very specific date and time that we pass in. Hey, what was the employee roster and their pay rate as of 6 months ago? Or we can do it as of right now. Once we have all of our information, you can see here's where we're actually going along and inserting the rows into that table variable. That's the variable name. They're the columns that we're inserting. And below is the list of the columns that we're selecting and the joins. This follows earlier examples where we're going out and figuring out the maximum pay rate based on the date the rate change occurred. So this should look somewhat familiar. And all we're doing is using those parameters that were sent in to filter out if we're looking for a given employee or a given department. So again, the point here is we're taking those parameters, using them in the select statement so that we get a more flexible, more reusable, more black box style approach to this function. So let's go ahead and execute this so we can actually create the function. And that was successful. So now we have the function defined. So we can go ahead and use that. And in this example, what we're going to do is we're going out to try to determine the total hourly cost per shift for our employees at AdventureWorks. And what we're going to do is we're doing some selection here where we're talking against the employee department history table, and we're also going to take a look at that function and bring back, remember that function goes and gets the details about the employees in a particular department and their pay rate. So what we're doing is we're going to go out and use that return table as something that we can join against, take a look at the summed rates that come back from that table, and we can take a look at the individual shifts at the plant and make sure that our costs are within reasonable boundaries. So let's take a look at doing that. Here you can see that we're going to look at all departments because our function was defined as either send me a specific department, or if you send me 0, I'm going to look at all. So we're going to be looking at all departments in the company, and we're going to do it as of today, the current date and time, and we'll take a look at what our costs are. So the thing to remember here or point out is here's our join to that function. And you might ask yourself, well, it sounds a little bit strange because I'm joining to a function, but remember that that function is returning a table. So I'm joining from one table to another table, and I'm passing in the arguments, 0 for the employee ID, so all employees, 0 for the department, all departments, current date and time. Let's go ahead and calculate what our salary costs are. So I'll go ahead and execute that. We're getting back the results. We joined against that table that was constructed by the function and returned, and you can see that we have a way of reusing that functionality that's now available to us to do further analysis with, and it's a way of creating these black boxes to make your queries more efficient. So let's continue our discussion on ways in which you can store temporary results and use them in your queries by talking about common table expressions. And CTEs are sort of like temporary views. They exist only for the duration of the execution of the query, but they're different from derived tables. They both receive rows, but SQL Server allows you to reference the CTE multiple times within the same scope. And this difference makes CTEs quite honestly a superior construct when querying a set of rows that you need to re-reference. Another option available to us is work tables, and what I mean by a work table in this context is something that's a permanent table within your database used to store data, but only on a temporary basis. Because they're permanent, they reside in TempDB, and that eliminates the overhead of creating and destroying the table dynamically. And you can think of a work table as basically a scratch pad. You get some results, you throw it in a table, you work with it later, and then you flush out the results. And finally, the user-defined table type parameter is a way of storing data and passing it along to another process. It provides the ability to define a table, populate it, and then send it to a procedure or function. If you want to create and use a user-defined table type parameter, you have to follow these steps. First, you have to declare it and define its structure. You then have to declare a variable that uses that user-defined data type. You have to populate the table with the rows that you're interested in. And then, of course, pass a reference to the table in the procedure or user-defined function call. So let's go to SQL Server Management Studio and we'll see how these are used. Here we are in SQL Server Management Studio, and we're going to take a look at using a common table expression, or CTE, for storing some results. And the reason that we're going to take a look at this is because of the CTE's unique ability to be referenced multiple times within the same scope while being a temporary object and not being a temporary table. So here we are looking at the definition here. We are going to store the employee last name, first name, title, and level within the organization, and that's the result of performing the select. And then what we're going to do is, this is the CTE structure, and it'll get populated by that select statement, and then down here we can actually reference that CTE because it is like a table or view, and we can access it now. And so what we're going to do is we're going to call it the first time. You can see right here. And that'll bring back information from the CTE for the employee. Then we're going to join it to itself. We're going to call it again, use it again, join it again to bring back the manager information. So we're using it one time to bring back the employee information, joining against it again, saying, hey, go get me the manager information. And if we do that, we'll see that this works pretty well. And we've gone ahead and produced the results of our employees and their managers using this neat little structure known as a common table expression. So right now I'm going to close this so we can move on to our next example. And in this example, we're talking about work tables. And these are what we consider to be a work table, but a permanent work table. It exists in your database. Its purpose is to be used for loading results and then retrieving them. And what this example shows is we're anticipating some of our queries are going to return large numbers of rows. And we don't want to return all of that data at one time over the network. We want to chunk it, so to speak. So what this does is create the table, loads up a whole bunch of data in that table, and then allows us to query from it asking for a particular number of rows. So you'll see here that our table structure is pretty simple. We are generating a unique ID for the table. We're going to generate a list ID, and what this means is that we're going to generate a unique ID for a set of data that's going to live there. Because it's a permanent structure in our database, we might have multiple lists existing at the same time, and we need to be able to identify our results. So we'll generate an ID to do that. And what we're going to do is just store product ID information in there so that we can use it later to select out the information specific to the product. Now, as I said, the purpose of this is we're anticipating lots and lots and lots of rows in the table, and this will be a little bit more efficient than trying to do it all in memory and push it over the network. So we're going to combine a couple of concepts here. We're going to use that work table, and we're going to create some stored procedures to populate and retrieve the information from that work table. Again, trying to get some reusability, some black box functionality, making your process a little more streamlined. So the first thing we're going to do is take a look at creating a procedure for populating that list. And we're going to select a bunch of records from our products table based on their price range. And so you can see here we're accepting the start and end of that range. You send in the parameter value saying, I want, give me a list of all the products we sell between $100 and $350, and it'll go out and generate this list. So if we get down to the meat of the procedure here, you can see that we're going to generate a new ID. Let me highlight that for you, which will identify our list. Remember, we're going to uniquely identify the list that we're going to stick in the work table. And then we're going to insert our rows. And we're going to rank our rows that we're selecting. We're going to do this by descending price, so most expensive to least expensive. We're going to go ahead and put the filter on for the list prices that we are interested in, and we'll take all of those rows and we'll store them into the table, right? We just inserted. So that's where we have all of that taken care of. So let's go back up to the top here for a second and let's start creating some of this stuff. So let's go ahead and we'll create the table itself to hold the information. And that was fine. We're then going to put an index on the list ID there. Not that we need it for the example, but it's good practice because, as we said, we're going to reuse this, and we expect to have lots of lists in there simultaneously, so we'll want it to be efficient. The next thing we talked about was creating the procedure to populate the list, so I'm going to go ahead and execute that. Make sure we get that taken care of, and that was successful. So now we're left with a procedure, again, for reusability, black box. We're going to create a procedure to select the results, and that procedure is right here. It's going to accept our list ID, which will identify the list we're interested in. It's also going to take in what row number we're going to start with. Remember, we're inserting many, many, many rows into this table, and we're going to indicate what row within the list to start and how many rows to return. So you can imagine we have, maybe a web app, and we're bringing back maybe 50 rows at a time to be efficient. So that's what this would support. And so what we're going to do is just down here in our select, we're going to select the top n rows based on what you pass in, and we'll bring back that information from that work table, joining on the list ID and where the row number is appropriate, and everything will be good. So let's go ahead and put our selection procedure into play, and that was taken care of successfully. And then very, very quickly, we have a procedure here that will clear out a list when we're done using it. So this is nothing more than a delete based on the list ID. So let's go ahead and complete that. And now we have the infrastructure in place, so to speak, for this example here, which is going to select out of that table some rows. First thing it's going to do is populate the list. We're looking for all of those products that are between $450 and $1,250. We will populate that work table. That procedure will return to us our unique ID, and then we'll go ahead and ask it to grab 10 rows and then another 10 rows, and we should see how this all comes together. So let's go ahead and execute that. And you can see here, if I can scroll this up for you, that we have two sets of rows coming back, 1 through 10 and 11 through 20. And we went through and used that work table, populated it, got our list ID, was able to reuse that functionality, and so it turned out to be a pretty efficient mechanism and a nice little black box to have. So let me go ahead and close these examples, and we'll finish up our discussion here by talking about a table valued parameter. And what we want to do here is remember that the first part of this process is we have to declare a type. And what we're going to do here is we are creating a data type that we're going to use. We're going to populate a table that will then be sent to our procedure to use. And what we're going to do is take a look at sales within the state or states that are contained in the table that we send in. So it's in effect behaving like a parameter, but we're actually sending in multiple rows to deal with it. In the past, we'd have to perhaps either have a parameter for each state code that we wanted to use, or perhaps even parse a string. So this makes it a little bit more straightforward. So I'm going to go ahead and create that type first. And that was just fine. Now we're going to create this procedure that is going to use it, and you can see here that we have some start and end sales dates, so we'll pick up sales within these states, within those dates. And you can see here is the table valued parameter type coming in. It is of the data type that we just defined, and we have to use the keyword read only. That's a SQL thing. That's how it works, so make sure that you put it there. And that indicates that we are passing in this parameter table. And then you'll see down here, we're actually going to take a look at that. We are joining against that multi-row parameter table coming in, and we'll use it in our query just like another table. And then we're off and able to use it. So let's go ahead and create this procedure. And that worked out just fine. And now, of course, we're left with how do we use it? Well, here I'm going to declare a table variable of this data type. It's actually I kind of misspoke there. It is a variable of this data type. That data type happens to be a table. And then we're going to populate it. Here I'm doing the inserts with those values, New York, Connecticut, Massachusetts. Then we'll execute our procedure and return back the results for those sales within that date range. So let's go ahead and execute this portion, and we should see how this turns out. And we're getting our summarized table coming back, indicating the number of sales and a total dollar value. And the point here is to let you know that this is a pretty neat little thing. The ability for us to be able to define a user-defined data type, which in fact is a table that we have now inserted rows into, and pass that along to a function or procedure where it can be used. So lots of choices available to us when we're trying to temporarily store some results. Take a look at all of them and choose the ones that most appropriately suit your needs.